Hello everyone, this is Samip and today I will be teaching you how you can fine-tune the latest version of Tesseract on Windows. So while working on my own project, I came across various issues while trying to train Tesseract on my own data, and since the documentation is not that great and there are very less tutorials for Tesseract version 5, I had to figure out main things myself. So in this video I'll share all the details and configurations you need to manage to do this stuff easily. So let's get started. So first of all, I suggest you to remove any existing installations of Tesseract you have, and we are going to be doing this tutorial on the latest version of Tesseract. I will have this link on the description, so just go to this page and download Tesseract version 5.4 from this file. So once you have it downloaded, let's just install it. So this part is pretty straightforward. So yeah, if you need any additional language, then you can choose it from here. So I'm just going to choose Nepali. So yeah, I'm going to choose Nepali and Devanagari in the script data. Then yeah, it's recommended that you do not change the directory. And yeah, the installation is done. So to verify this, just open your command prompt, then type in Tesseract version. So yeah, as you can see, Tesseract version 5.4 is now installed on my computer. And so after installing Tesseract, you will need to install Git because we will need Git bash to run the training scripts. So I already have it installed, and you might have it as well, but if you don't, then just go to the link in the description. The installation is pretty straightforward, so you can just download the exe file and run it. So after installing Git, you will see something called Git bash here. So you can just open it and verify the Git installation as well. You can do this from the command prompt as well. So the most important thing is you need to have Git bash available here. Okay, so once you have Git and Tesseract set up, now we need to install something called Windows Package Manager. So the link will be on the description as well. So actually most of the times it comes pre-installed with Windows 10 or 11. So before installing, just check if it is already installed. So I can type in Winget and version. So yeah, it's already installed in mine, and chances are that it's already installed in yours too. So if it is not, then you can go to this link, and it is a link to the app installer from Microsoft Store. So once you install this app, the Winget will also get installed, and then you can verify using the command that I just wrote. So after installing Winget, we have to use Winget to install two more packages. So the first one is called make. So this is the command through which we will be executing our training script. So just go to this test train repo, and here is the command. I'm going to copy it and paste it in my terminal. So it will install the package. Okay, so to verify this, we can again check the version. So yeah, as you can see, make is now successfully installed. We also have to install wget, so copy the second command and paste it here. Okay, so we can verify this as well. So yeah, we have all of the prerequisites installed. So yeah, let's proceed. Okay, so I'm going to assume you already have Python installed, so if you do not, then install that as well. So we're now going to clone this test train repository, so the links will be in the description. So let's just copy it and clone it. So I'll just create a folder and clone it using git bash. You can use command prompt or PowerShell as well. So this is the folder that we will be using to fine-tune Tesseract. Okay, so now let's talk about the dataset. So inside test train repo, you will find one folder named OCRD test set. So this is the sample default dataset which I am going to be using today. So just extract it, and inside it you will find the data format. So unlike Tesseract 4 and earlier versions, you only train Tesseract 5 on single line images. So for each data sample you will have a single line image like this and its corresponding ground truth file in format .gt.txt. Basically it should contain whatever the text that is there in the single line images. So, and you don't need to make any box files, Tesseract will create it itself. And this is my another example of Nepali dataset that I have been using. So the image should contain a single line in PNG or TIF format, and then you have the corresponding ground truth file. So once you have a dataset ready, inside the test train folder, create a new folder named data. And then move your data to this folder. I'm going to copy the OCRD folder here. So, and now you need to rename this folder. So the name format should be whatever the name of your new model is going to be. For now, I'm just going to put it as the name of my YouTube channel, SL7 Tech. So after that, give a single dash, then ground, then again dash, then truth. So remember to name it in this format, otherwise we'll have to give the custom path. So, and this folder should contain the image and its corresponding ground truth. Okay, so the next step is to download the already existing model for which you are trying to fine tune. So you need to go to the test data best repository, the link will be in the description, and then download the model. So the sample dataset is based on the Frankish language, and this one is the existing model for that language. So I'm just going to download the raw file. So once you have it downloaded, go to your test train folder. First copy this, and move one step outside your test train folder and create a folder called test data. And then paste your downloaded model into this folder. So let's go back to test train. Okay, so now we are going to train the model. So go to the test train directory, then shift right click, and you can open git bash from here. So you cannot use command prompt.powershell, you must use git bash in this step. So now we're going to be running the training command. So you can find this in the test train repository. So it has a detailed documentation on all the settings you can adjust. So I'm just going to show a basic command. So we're going to be using the make training command, right? Make training, and then the model name. So the model name is the one we renamed our data folder to initially. So I had kept SL7 tech, so you can keep whatever you kept in that folder. And then we need to specify what is the start model, so the model we are going to fine tune on. So since we downloaded the Frankish language model, so let's go to test data and check its name. So I'm just going to copy this name and paste it in start model. And then we also need to provide the test data directory. So ours is just one step outside the parent folder and then inside the test data folder. And then you have other settings as well. So you can define the number of iterations. So if you leave it, it's going to go till 10,000 by default. So for now I'm going to choose a really small number just to show in the video. Maybe something around 500 for now. And then you have other settings as well. You can adjust the learning rate. Then you can also change the train and eval split ratio. So the default is 90-10. I'm going to leave it as that for now. And another important part is this language type. So depending on the script you're training, if it's like Devanagari scripts for Indian Nepali scripts, then you need to specify as Indic. And if it's like Arabic text, then you need to specify as RTL. RTL means right to left. Or if it's normal scripts like English, then you can just leave it as blank. So I'm going to leave it blank for now. Then you have other settings as well you can modify, but training will run on this command as well. So hit enter and the training will start. Okay, so first of all, it will loop through our dataset and generate the box files individually. So you can check this test train repository to know how it works, or if you want to modify something from the inside. So yeah, error scripts like generate line box, generate word box. So these scripts are executed depending on the settings we pass through the training command. So you can go through this to find out the functionality. So for now, let's just let it complete. So this will take some time. So these are generated only in the first time you're training a certain model. So now it will download the language data from its server. So now the training will finally start. As you can see, the settings we have passed is displayed here too. So like the next time you want to train to more iterations, you will simply resume from the same point you left before, and all of these do not need to be done. So when you write make training the next time, it will simply continue from this step. And so the training is happening on our CPU. So Tesseract does not utilize GPU, so there is no way you can train it with GPU. So it does not take that much of time, but it will take a certain amount of time. But the training is happening with our CPU. Okay, so once the training is complete, you will find the error log here. So it is going to give updates at each 100 iterations. If you see here, then it's going to give the character error rate and word error rate at each 100 iterations, and this is also stored in the log file. So you can find this in if you go inside the test train folder, you can go inside the data and then the name of your model SL7 tech here, and then you can check this training.log file. So yeah, the output is stored here. So for each 100 iterations the data is present here. So the training is now complete. Okay, so to use the model you need to go outside of this your model folder, then you will find the train data file here. So to use this model, all you need to do is copy this file and then go to your Tesseract installation directory. So by default it's in program files and Tesseract OCR. Then inside the test data folder you will need to paste this model, and let's see how we can use it. I'm going to open VS Code. I'm going to open our folder. Okay, so let's just create a new notebook here. So you need to have PyTesseract installed and Pilo as well to load the image. So let's just load one of the images. I'll just take one from the dataset, as I do not have other data of that language. So to use this model, while passing it with any method of Tesseract, so in the language section you need to mention the name of your train data file or the model file, and in this case the name of my model was SL7 tech, so it will run Tesseract on that model. So let's just check if it is running or not. So yeah, as you can see this is running. So after you train your model and once you have pasted it in the test data directory, your model will work. Now I'll just say a few more things about the model. So if you want to extract the model from a previous checkpoint, so if you go to the model folder, then you will see a folder named checkpoints. So these are the checkpoints that are available. So you need to create the train data file of these checkpoints. So if I just go to test train again and open git bash and run the command make train data, oh, I think we need to pass the model name as well. So this command will just create the model file out of the checkpoints. So now if I go to the data folder, then SL7 tech again, and so yeah, there's this another folder called test data best. So if I go inside this folder, then this is my checkpoints model file saved at 100 iterations. This one is 400 and this one is 500, so I can utilize any one of these as well. Okay, so the next thing is about calculating the evaluation metrics. So the training character error rate and word error rate are already stored in the training.log file. We can retrieve it from that file manually or using regular expressions. But to compute the evaluation metrics on the eval dataset, So you need to actually run these commands, make evaluation, or you can directly run make plot. But it is not working on my device for some reason, and if it is not working on yours too, you can simply follow my notebook. I will upload it in my Git repository. So there is this eval.ipynb file. Simply move it into test train, and then you can execute the cells one by one. And I have found a workaround to retrieve the evaluation metrics and training metrics both at once. So you can run this notebook. Just remember to change the model name wherever there is. So I think it's in two places. First one is here, and the second one is I think cell number 18. Yeah, second one is here. So if you replace it with your model name, then this will work as well. And so I have retrieved both training error and eval error, and I have also made plot of character error rate and word error rate. So if the original command does not work on your device too, then you can follow my notebook. So yeah, that is all for my video. If you liked it and if this worked for you, make sure to like this video and subscribe to my channel. Also, if you have any issues, then you can drop them in the comment section below and I'll try to help. Thanks for watching.